Hi, my name is Ben Civillo, and this is an overview of my project Modular Effects Rack for the Circuit Cellar ECE 4960 for spring 2023. My motivation for this project was to improve upon the classical ways of implementing these audio electronic prototypes. Traditionally, this is done with the stomp box method, where you would buy an aluminum chassis, which can be pretty expensive, usually $8 to $12, and you would drill into the aluminum chassis to mount your hardware. This method has a lot of downsides. It's very cramped, and it can be hard to hook everything up. There's a lot of different sized boxes, so you need to do a lot of planning to make sure everything is going to fit correctly. Because the box is aluminum, you can short things to the chassis, which I've had some trouble with in the past. And the way that I'm going to fix this is by using the Eurorack standard, which is a synth modular standard that's used for synthesizer components. And this will emulate that. However, this is meant to work on a line level, instrument level effects, whereas synthesizers are 12 volt, meant to be producing the full wave that does not need to be amplified. The chassis development was quite simple. I designed it to hold 8 different modules, and they would be 2 rows of 4. I used a laser cutter to cut all of the pieces to make this chassis. I made it out of composite wood because I didn't need a very robust chassis, because this is meant to be sitting on a desk in a studio. The chassis will also have to hold a 9-volt power supply, which can provide power for the full 8 modules if you have all of that hooked up at once. For the mounting racks, this is meant to hold the hardware and also the printed circuit board. I went with a 3D printable model. So I developed a base model in a CAD software. I used Fusion 360, and I made this to hold the 3U size circuit boards, which is a very standard size. The mounting holes can be added inside of the CAD software onto your base 3D model to customize the layout for any effect that you would want to implement with this mounting rack. This method creates a very cheap way to house your electronics. For one base model, it takes about $1.50 of material and about 2.5 hours to print. This is very easy to assemble in because it's so open, and the hardware is very accessible. To test my new system, I decided to implement 2 different modules into my rack, and the first one is the 7-band equalizer. The picture on the top is the footprint of the printed circuit board layout, and the one on the bottom left is the physical PCB that was printed out by JLC PCB. So the 7-band equalizer uses a series of bandpass filters to control the frequency response of your signal. I used a graphical filtering technique which achieves a more ideal frequency response without the additions of multiple stages of filtering. It removes a lot of components by adding an active component, which is the transistor. The printed circuit board was made in EagleCAD, and the fabrication was outsourced to JLC PCB, and I used double-sided etching. The next module that I implemented is a PT2399 based delay effect. This delay effect uses a very common chip for audio processing, which is the PT2399. It is a digital processing chip, and the base way that this chip works is it records up to 300 milliseconds of audio, and it'll replay that audio at a set interval at a set amount of attenuation. So for example, if I use my potentiometer to change the interval time, I could record 100 milliseconds of audio, and I could change it with another potentiometer, change the attenuation, and have that repeat back to me with a type of fading out effect with the attenuation per cycle. So for example, I could record 100 milliseconds of audio and then play it back forever if I had zero attenuation on that wave, or it wouldn't play back at all if I had a 100% attenuation. And you can make many different audio effects with this. It's very versatile and is a very common effect when looking at audio effects. This printed circuit board was made in EagleCAD, and the fabrication was also outsourced to JLC PCB. However, I used single-sided etching because when I made this design, I was under the impression that I could use an in-house milling machine to create this. So looking at this project as a whole, the chassis comfortably fits 8 modules. It provides a 9-volt power supply for all 8 potential modules, but the real test for this was the reason that I decided to implement 2 prototypes, which would be the 7-band equalizer and the delay effect. That was really going to be the test to see if this was actually a cheaper method and if it would be an easier method. And I specifically chose the 7-band equalizer because it has a lot of hardware associated with it, and that would be a really good test because I know that would be a very difficult module to implement into the stomp box method. So I'm only going to be relying on my experience for implementing both of these because I've used the stomp box method before and now I'm testing it with this. So my thoughts on implementing both of these effects is that it was much easier. It is a huge improvement. I had to spend hours less researching the dimensions of everything and making sure that I could fit all of my hardware onto the box and also have room to mount my printed circuit board. And it saved a lot of time for that. The other part that it saved a lot of time on is actually the assembly stage, because this module is so open. You have easy access to all of your hardware and easy access to your printed circuit board. So it makes hooking everything up much faster, and it definitely saves hours compared to the stomp box method. The cost reduction is very good as well. It's 83% cost reduction compared to implementing the same module onto a stomp box. So that will make future implementations very nice as well. It's also very easy to reorganize the modules inside of the case. You just unplug the power and you can take it out. It's very modular. Thank you for listening.